Hello guys, and welcome back to our channel. In today's video, we're looking at the correction of ATC mock March 2021 paper 1. ATC mock March 2021 paper 1. Guys, please don't forget to subscribe to our channel and to leave your comments. You can equally give us proposals on particular papers you would like us to answer, but most importantly, don't forget to subscribe so that when we upload a new video, you will be notified. Now, the first question reads, find the distance between minus 54 and minus 2. So how do we do this calculation? Here, we just have to say minus 54 minus 32, and we take the absolute value because we know that distance is always positive. So what will this give us? So if you do the calculation, if you take minus 32 minus 54, what are you going to have? You are going to have 22 as the distance, okay? Even if you take the other one at the end, the distance should always be positive. Distance should always be positive. So here, our key is going to be, yes, of course, our key is B. Our key is B. Now, the next question, question number 2, we have 1 over x squared minus 4 plus 2 over x minus 2. To simplify this, normally from here, we know that the LCM is x squared minus 4. And why is that? That's because we know that x squared minus 4 can be written as x minus 2 into x minus 2. So we can look for the LCM, right? So we have a bracket open, x minus 2 into x plus 2, right? So this is what we have. Now, since this is the LCM, at this point, if we take x squared divided by, if we take x squared, that's x minus 2 into x plus 2, and we divide this by this x squared minus 4, we are going to have, here at this point, we are going to have x minus 2 into x plus 2, all that over x minus 2 into x plus 2. So all of this is going to give us 1 at this point. So plus at this point, we are going to have, dividing this right-hand side, we are going to have 2 into all of this expression. So you're going to have 2 into what value? 2 into x plus 2, okay? So altogether, this is going to give us, at this point, we are going to have, please excuse me, I have a bit of network issue. All right, so at this point, we are going to have 1, that's the first element, is going to be 1. Now plus 2 into x plus 2, of course, x plus 2, thank you. So x plus 2, and when you open out this bracket, that's going to give us 2x plus 2 times 2 is 4 plus 1, 5. So what does this give us? This gives us this second case when we simplify, okay? So our answer is going to be equal to B. That's why we have our answer to be B. So our answer is B. The next question, question number 3, we have the value of t for which t over t plus 1 minus t 1 over t plus 2 equals 1 is. So here we just need to cross multiply. And when we cross multiply, what are we going to have here? So if you cross multiply, we are going to have t plus 2, that's t plus 2 minus 1 into t plus 1 plus 1. All of this should be equal to t plus 2 into t plus 1, right? Of course, t plus 2 into t plus 1. So that's going to give us t squared plus 3t's plus 2. right? So we have t squared into 3t plus 2. So we have a square at this position. T squared is 3t plus 2. And with this, if we simplify and work out the solution, we'll end with C as the solution. Or equally, we can equally test here. Yeah, knowing that this is 1, or is it T? I am very sure this is 1. So when we work, this is what we are going to end at. All right, the next question, this is not actually not much of a problem. Question 4, the range of values of x for which this is greater than 0 is? The range of values for x for which this is greater than 0 is? So the boundary solutions here, first of all, are, we have x equals 3 and x equals minus 7. So those are the boundary solutions. Now that we have the boundary solutions, we can write them as follows. So we have the boundary solutions. So we have from, because normally 3 and minus 7 are included, so we can test for these test these various regions. Let us use a number line to test, and we see what we obtain. So what will this give us? So considering that this is a number line that we have, let me put it here. This is a number line. Okay, so at this point we have 3. Why here we have negative 7? All right, let me do it this way. Let me do it this way. So we have 3. And we have 3 here. So let's assume that this is a number line. We have this number line. We have to test the regions. Which of the regions is going to satisfy this? If we take a number between minus 7 and 3 to test, so let's take 0 for example and test in this inequality. 3 minus 0 is 3 is positive, and 7 plus 0 is 7, which is positive. Positive times positive is positive. So the region between gives us a value that is positive, right? Now let us take a value that is less than 7, for example, negative 8. So 3 minus minus 8, this one is positive, and 7 minus 8 is negative. Positive times negative is negative. So this region before 7 does not satisfy. And if we take a number greater than 3, it will not also satisfy. So our answer should range from negative 7 to 3. And the truth is, negative 7 and 3 are included. That is why the answer is D, not C. Because with C has a problem because 3 is excluded. But according to this inequality, it has the equal to sign here. So that's why the key to this problem is D. So the key is D. Now, the next question, question number 5. Given that P of x equals that is exactly divisible by x squared minus 1, then what are the values of A and B respectively? Now here we have to note that x squared minus 1 is the same as x plus 1 into x minus 1. So these are the factors, right? Which therefore means that we can have when x is equal to 1 and when x is equal to negative 1. So these are the values that we have. So it therefore means that P of 1 equals 0 and P of negative 1 equals 0. So for P of 1 equals 0, what are the inequalities that we are going to have? For P of 1 equals 0, we are going to have, the equation 1 plus A plus B minus 2 to be equal to 0. That is P of 1 equal to 0, right? And from here, this equation is going to give us A plus B is equal to 1. So when we simplify, we're going to have A plus B to be equal to 1. And for P of x negative 1 equals 0, we are going to have negative 1 plus A minus B minus 2 to be equal to 0. And if you work out this equation, we are equally going to have A minus B to be equal to 3. So simplifying this will give us A minus B to be equal to 3. So from here, 2A is equal to 3. 2A is equal to 4. So A is equal to 2. And if A is equal to 2, what will be the value of B? B should be equal to negative 1. So what are the solutions here? We have -2, that we have, sorry, we have +2 and -1. So we have +2 and -1. So what is the key here? Of course, the key here is A. The key here is A. Question number 6. Question number 6, we have the value of k greater than 0 for which this equation has equal roots. What is the condition for equal roots, guys? We know that for equal roots, b squared minus 4ac, right, should be equal to 0. So b squared minus 4ac should be equal to 0. And here our b is -7. So -7 squared is 49 minus 4 times a. 4 times 1 is 4 times k squared. So minus k, 4k squared should be equal to 0. And if we solve for k here, k is going to be equal to plus or minus 7 on 2, right? But since k should be positive, we take only the value of k, which is positive, because they say k must be greater than 0. So in this case, our solution is going to be A, because they said k should be greater than 0. Question number 7. Given that x cubed over x into x minus 3 is identical to this, then the values of A and B respectively are, the values of A and B respectively are, so with this equally, if you look at this very well, we can simplify this to have something else like x squared over x minus 3. So if you use long division, since from here you can see that x into x minus 3, when we divide, we are going to see what we can obtain. Then we express it in partial fractions. So how do we proceed? Normally this should be equal to x to the power 3. Why? How do I know that it's x to the power 3? Because I can see that the numerator has a degree of 3, the denominator has a degree of 2. That's why when we divide, we are going to have this x minus 3 here. So if we are to do long division here, because since the degree of numerator is greater than that of denominator, it is good that we do long division first of all, as you have been told in school, right? So doing long division, we are going to have this, and then, so this is what we have. So at this point here now, we have our x cube outside. We have our x cube. So here we have x cube. And outside, what do we have? So outside here, we are going to have, x into x into x minus 3. X into x minus 3. Now, this x into x minus 3 is like we have x squared here. So x squared divided by x squared is going to give us x. So at this position here, we have x. So that will be equal to x. And x now times this x squared, or x into x, all of this, is going to give us x squared times x, which is x cubed. So this will give us x cubed. So here we have x cubed. Then x times minus 3x, so x cubed minus x squared minus x squared. And when we subtract all of this, we are going to end up with x cubed minus x cubed 0, and then we have nothing minus x squared, so that's going to give us minus x squared. So we have minus x squared. Now minus x squared divided by this x squared again here is going to give us minus 1. Minus 1 times 3. Minus 1 times x squared is going to give us minus x squared. And minus 1 times minus 3x, so minus 3x. We subtract again, we are going to be left with 3x. So normally this one here is not supposed to be 3, it should normally be 1. So this position, you have an issue. So we are now left to express 3x over x into x minus 3 into partial fractions. But 3x on x into x minus 3 is the same as 3 over x into x minus 3. The x can cancel out and be left with just 3, which matches this part of the equation. So our b is equal to 3. And of course, our a will be equal to 0. So that's why this one is the root of, or the value of, the value refers to the values of a and b. Now, number 8, we have the function this defined as x squared minus 4x plus 4. So it intersects the x-axis at the point. A curve intersects the x-axis at the point where y is equal to 0. So if you solve this quadratic, the value of x will be, using any method that you want to use, the value of x will be, it has repeated roots. So we have x equals 2, when y equals 0, and y equals 0 because it cuts the x-axis. Y equals 0. So it therefore means that the point where it intersects the x-axis is the point 2, 0. 2, 0. So this gives us a for this root, 2, 0. Question number 9. Guys, don't forget to subscribe and to watch this video to the end. So question number 9, we have the value of x for which 4x squared minus 4 to the power x squared minus 24 is equal to 16 to the power x r. So we have to find the values of x here. And for us to find these values, we have to start by looking at this point. So here we are going to have, we can express everything to make them to have a common base that we can equate the powers. We are going to have 2 to the power 2, that is 4. 4 is the same as 2 to the power 2. And then we have x squared minus 24. And this should be equal to 2 to the power 4x, because you know 16 is the same as 2 to the power 4. So this one is the same as this. At this point, we have 2x squared minus 24 to be equal to 4x. You can divide all through by 2 and be left with x squared minus 24 to be equal to 2x, right? So this is normally just for the powers, and this quadratic can finally be equal to, we have x squared minus 2x minus 24. And when you solve this quadratic equals 0, the root of this quadratic will be, so for the roots of this quadratic, when you factorize, actually, you have x minus, we have 6 times 4x minus 6 into x plus 4 equals 0. Or if you use another method, this is what you still have, x plus 4 equals 0. So what will be the values of x? The values of x should be equal to 6 and negative 4. So those are going to be the values of x. The values of x should be 6 and negative 4. Let us see what you have on the paper for the values of x. So for the values of x at this point, we have 6 and negative 4. So we have b. So that gives us b, 6 and negative 4. B, 6 and negative 4. All right, the next question reads, the first term of this sequence Tn equals 16 to the power 3, 16 into 3 to the power n minus 1 for every n element of the set of natural numbers is. So since it's a set of natural numbers, the first natural number is 0. So the first term will occur when n is equal to 0. So we'll have 16 into 3 to the power 0 minus 1, that is 16 into 3 to the power minus 1, which is just equal to 16 on 3. So that will be equal to 16 on 3. Do we have 16 on 3? So the answer here is C. Now, if you don't know what natural numbers are, natural numbers begin from 0 So somebody who does not know will start from 1, and we'll have 3 to the power 1 minus 1 is 3 to the power 0, 16 times this, and somebody will choose this answer as A. So these students who choose this one is wrong. The correct answer here is C. If they set n star will mean that the first element is 1. So be very careful with n and n star. N star means exclude 0. N means begin from 0. All right, the next question, question number 11. Given the probability of selecting a queen from a pack of 52 is, so from a pack of 52, how many queens are there? In a pack of 52 playing cards, there are 4 queens. 4 queens out of how many cards? Out of 52 playing cards. And what is 4 divided by 52? 4 divided by 52 is equal to 1 on 13. So our key here is A. Question number 13. The distance in centimeters between this point and this point on a rectangular coordinate system is, of course, you know the formula, right? So the formula for this one to find the distance between these points should just be equal to, you can do it directly, should be the square root of the first element that we have here. So this should be equal to the square root of 1 minus 1 all squared. 1 minus 1 or minus 1 squared just give us 2 squared, which is 4. And plus 4 minus 5 is minus 1 squared. So it's 1. So this solution is equal to root 5. So this gives us root 5. Question 14, we have given that f of x on g of x is equal to q of x plus p of x on g of x, then the polynomial p of x is called. So first of all, let me throw light on this. We know that for polynomial division, dividend divided by divisor. So the dividend here is f of x divided by divisor, which is g of x, is equal to the quotient. So this is the quotient plus the remainder. The remainder is p of x. The remainder is p of x. Now all that on g of x. So how do we call this function p of x? It is called the remainder. So this function is called the remainder. Okay. Now the next question, question 15, we have the first derivative of this function is, now the derivative of exponential functions is just equal to the derivative of this power times the function itself. And the derivative of this power is 3x squared. So 3x squared times this function back is going to give us 3x squared e to the power 3x plus 2. So the key here is C. Question 16. Question 16. We have the sum of the first n terms of a sequence is Sn equals n into 1 plus 2n ln 2. The fifth term of this sequence is, this is a equation that many students always fail. This sequence has been defined in terms of the sum. So for you to have the nth term, you have to look for the sum of the first n terms minus the sum of the first n minus 1 terms. What am I saying? In this particular case, the fifth term should be equal to the sum of the first 5 terms minus the sum of the first 4 terms. Okay, so we have to look for the sum of the first 5 terms. And how do we get the sum of the first 5 terms? That should occur when n is equal to 5, right? So the sum of the first 5 terms, let us call it S5, will be equal to 5 into 1 plus 2 times 5, that is 11 ln 2. So this is the sum of the first 5 terms. What's the sum of the first 4 terms? Sum of the first 4 terms should be equal to 4 into 2 times 4, 8 plus 1, 9. So into 9 ln 2. So now the nth term, the fifth term, let us call it C5. The fifth term now should be equal to S5 minus S4. What did that give us? That will give us 55 ln 2 minus 36 ln 2. And that will give us 19 ln 2. So that's 19 ln 2. So our key here is C. So these students do not have the answer correctly. 19 ln 2. Okay, question number 17. The region of the shaded region in this figure is, so what is this shaded region? This shaded region is the integral of this curve, the integral of f of x should be the integral of f of x from 0 to a of f of x dx plus the integral now from where to where? From a to b, the integral now from a to b of f of x dx. Now, one other thing that I emphasize here is that normally for this curve, since this area is below, normally this one has to have this sign. This first part has to have this sign because it's supposed to be an absolute value. Now we cannot talk about negative area. So the total area here should be equal to the absolute value of this small area that looks like a triangle plus this other area that looks like that is somehow parabolic, because this is how this curve is like. Okay, question number 17. So the key here is A. The key here is A. Key here is A, the plus, not this one. Don't talk about the difference in areas. All right, question number 18. Question number 18, we have, given that two circles, this and this, are orthogonal, then the equation of their common chord is, so orthogonal circles are circles that meet at right angle sides. So for us to have the equation of the common chord here, we just have to subtract one equation from the other. We just have to subtract one from the other, or we can talk about equating the two. So if we equate these two equations, these two circles rather, we are going to have minus 6x plus 4y. The terms in x squared on both sides are going to cancel out now. Plus 4y plus 2 should be equal to this other one, should be equal to 8x plus 2y minus 22. So in the next step, we are going to have, let us bring the y's on the left-hand side. We are going to have 2y's to be equal to, carry the x on the right-hand side, 14x minus what? Minus 24. Minus 24. We can divide all through by 2, have y to be equal to 7x minus 12. So you can see clearly here that the key is A. So that will be the equation of their common chords. Question number 19. Guys, don't forget to subscribe and to leave your comments. In case you have any issues with any question, please, you can leave your comments. Question number 19. Given that x minus 1 is a repeated factor of f of x equals x cubed plus px plus q, then the values of p and q are respectively, so it's a repeated factor, right? Good. So now the values of p and q are respectively. So with this particular question, if they are repeated factors, let's see what happens. So when x is equal to 1, what are we going to have? So if x equals 1 for this polynomial, we are going to have f of 1 should be equal to 0, right? So we have 1 plus px, that is plus p plus q to be equal to 0. So therefore p plus q should be equal to minus 1. Now, since they have said that it is a repeated factor, it means that the other factor is also x equals 1. So in this particular case, how do we solve this type of question? To solve this type of question, if we have to go by the normal procedures, we need another equation. But there is one other thing that can help us. So with this type, I give you a shortcut. Go to the answers. Any two answers whose sum is equal to minus 1 is the correct answer. 2 plus 3 equals 5. It is wrong. Minus 3 minus plus minus 2 gives us minus 5. It is not, so it does not match here. Minus 3 plus 2 matches our equation. So our result here is C. That's a very, very good shortcut. The result here is C. So with this type of questions, this is how you answer. Some multiple choice questions require that you use by the answers that have been given to test. Now find this integral, the integral from 0 to 1 of 3x dx. And how do we integrate this type of functions? Many students always fear this particular question. How do we integrate this type of functions? So to integrate a function whose base is not e, we have to do this. So here we have to start by writing it as follows. We take e, look at it very well, to the ln. Now you write the function. Ln what? Ln 3 to the power x. You now put your dx here and your integral sign. Okay. So when you integrate this now, or now this can actually be written as e to the x. I'm bringing the x in front. Ln 3 e to the x ln 3 dx. Please look at this procedure very well. If you don't understand this, you can look at our past videos on integration of exponential functions. We have all of this there. Now, this one is just like the integral of the function e to the power ax. Because this ln 3 now is a constant, you can call the constant like our a. When you integrate e to the power ax, the answer is equal to 1 over a e to the ax. So the integral of this will be equal to 1 all over a, our a is ln 3, and e back, this function itself back e to the x ln 3. But we know that e to the power x ln 3 is just the same as 3 to the power x. So when you integrate, you're going to have 3 to the power x, all that on ln 3. And then we take the limits of integration from 0 to 1. So when x equals 1, we have 3 over ln 3. And when x equals 0, you have 1 minus ln 3, right? So this will give us 3 minus 1, all this on ln 3, which is the common denominator. So this gives us 2 on ln 3. So that's why the answer here is C. 2 on ln 3. When you integrate, you have 2 on ln 3. Question number 21. Question number 21. The domain of definition of this function is, so the domain of definition of the function g of x equals x minus 1 to the power, x minus 1 on x to the power a half is. So for you to get this domain of definition, there is a rule to find this, right? So for us to get the domain of definition of this function, these are the inequalities that we had to satisfy. X minus 1, all this on what? On x should be greater than or equal to 0. And secondly, the denominator should not be equal to 0. X should not be equal to 0. X should not be equal to 0. So we can test the regions now of this inequality. Okay, because the boundary solutions, we have 0 and we have 1. So we have from 0 to 1. Let us use the number line to test. So at this point here, we have 0. And here we have 1. But 0 is not included. So 0 is not included, while 1 is included. So I'm going to shade here because 1 is included. Now let us test any value between 0 and 1. For example, a half. So a half minus 1 is minus a half. All this one, so this one is negative. Is a negative number greater than 0? No. So this region does not satisfy. Let's take a number greater than 1, for example, 2. If we take 2 and test here, this region will be satisfied because the answer will be greater than 0. And if you take a number less than 0, it also satisfies. So our domain of definition is from negative infinity to 1, but 1 is not included. I'm sorry, negative infinity to 0, but 0 is not included. We can see the case here already. So this case like this is not correct because 0 is included. This case is wrong. And this case is also wrong. You can clearly see that our answer is going to be this one, B. Okay, so it's from negative infinity to 0, but 0 is not included. And from 1 to positive infinity. Okay, and from 1 to positive infinity. Okay, so we can begin to see now here that, see, if you look at this, 1 is included. 1 is included, so this is the correct answer, but here 1 is not included, so this one is wrong. So our domain of definition is this. So the answer here is D. So we have D. So you have to be very careful with this one. I equally have past videos on domain of definition that is focused on this. Please go to YouTube and check our videos on domain of definitions of functions. We have looked at all the different types of exponential functions, and most of these functions have been trashed there. So please go to YouTube, GCE Math panel, and you see all of these functions that have been trashed there. Question number 22, students said we are very fast. That's why we are taking this video very slow. Yes, we apologize about that. We have to take it at their pace. They are the ones consuming it, so we have to follow what they tell us to do. So when we simplify this, what are we going to have? So we can start by writing this as log. We can express it the common base. The common base here should be 2 to the power 4. 2 to the power 4, while 32 is the same as 2 to the power 5. We can now bring these powers in front, and we will have, when you bring the power of this base in front, you are going to have 5. But if the power is at the base, it is 1 over that power. So we are going to have 5 on 4, log 2 base 2. But log 2 base 2 is equal to 1. So 5 on 4 times 1 is just equal to 5 on 4. So the answer here is 5 on 4. Question 23. The inverse of this function is, so to find the inverse of this function, they just want us to solve for x. Whenever I talk about inverse of a function, just solve for x. So here, for us to solve for x, we will say, let this f of x here be equal to y. Let this one be equal to y. So if we solve for x now, we start by taking e to the power, to the both sides, on both sides. So e to the power y should be equal to e to this value on the right-hand side. So on the left-hand side, we're going to have e to the power y. This should be equal to, for the right-hand side, when we take e to the ln anything, it's equal to that same thing. So this will give us x plus 1 on x. X plus 1, all this on x. So now we have xe to the power y minus x to be equal to 1. And from here, we make x the subject of the formula. Our x now will be equal to 1 over e to the power y minus 1. So our inverse function should be equal to this. Okay, so this will be equal to 1, all this over e to the power y minus 1, which we now replace this value of y by x. So that is why the inverse of this function is d. So c is not correct. So you have to be very careful with that. It is d. Now, question number 24. Guys, don't forget to watch the paper 2 of this paper. And if the other papers would like us to work on, then you can equally send the link or send it to us on WhatsApp directly, like students and teachers send, so that we can work on those papers for you. We are here to serve you. So the value of x for which e to the power 4x plus that is equal to 0 is. So this one is a direct question. What I'll do is that I'll just carry the this e to the x to the other side. And what will that give me? The powers will now be the same. So this will now give us 4x plus 5 to be equal to x minus 2. This one is a small thing for you people now, x minus 2. So at this point now, we'll have 3x to be equal to what value? So 3x will be equal to minus 2 minus 5 is minus 7, right? So we divide both sides by 3, x will be equal to minus 7 on 3. X will be equal to minus 7 on 3. We have come to half of this paper, and half of the paper has been answered in about 30 or 35 minutes. So just in 1 hour, I can answer all of this paper that is given for 1 hour, 30 minutes. Question 26, don't forget to subscribe, guys. Don't forget to subscribe. That's the only way that you can support us in this channel. Don't forget to subscribe and to share the video. Question number 26, given that y is equal to ln x minus 1, then y is defined if, so they just want the domain of this function now. So this function is going to be defined if this x minus 1 is strictly greater than 0. So if x minus 1 is strictly greater than 0. So it is defined if x is strictly greater than 0. I'm sorry, now 0 plus 1, which is 1. So this is the domain of this function, which they are indirectly asking for. Now, question 27, given the probability distribution of x as this, then the mathematical expectation is, so the expectation is defined as the summation of x times p of x. X times p of x. So this will be equal to 0 times 0.4, that is 0, plus 1 times 0.5, plus 0.5, plus 2 times 0.05, plus 0.1, plus 3 times 0.1, so plus 0.3. When we add all of this, we are going to have 3 plus 1, 4 plus 5, 9. So this gives us 0.9. 0.9. So our key here is B. Question number 28. The curve below is guided by the following asymptotes. So the asymptotes of this curve, we have x equals -1, x equals 2. These are the two vertical asymptotes. And we have an oblique asymptote, the line y equals x plus 1. So what will be the center of symmetry? Normally, for us to find the center of symmetry when we have two oblique asymptotes, the center is given by what? The center is given by the average of the two oblique asymptotes. So -1 plus 2 divided by 2. That is going to be equal to a half, right? So we have a half. And now we take this value and substitute in this oblique asymptote to have the y value. A half plus 1 is 3 on 2. So plus 3 on 2. So this is our center of symmetry, C. That's the center of symmetry of this curve. All right, the next question, question number 29. The graph of the function f has a parabolic branch in the y direction only if, yeah, this question is direct. So a parabolic branch, like the asymptote is like a curve. This first case is not true. If it's 0 or it's a constant, in fact, all of these are constants. And there is nothing, we don't have any test like this one. This is the only test that we have. This is the test for parabolic branches. If the limit as of f of x as x of f of x on x as x tends plus or minus infinity is equal to plus or minus infinity, any of them, whether plus or minus, then it means that there is a parabolic branch in the y direction. So this is what we have. Then for question number 30, the sum to infinity of this sequence is given by the sum to infinity. They have omitted, it seems as if they have omitted one term. So let us work with what we have. Let's work with what we have. So the sum to infinity will be equal to, how do you get the sum to infinity? It's given by a over 1 minus r. Here, our a is equal to 3. So we have 3, all this over 1 minus 1 on 3. 1 minus 1/3 is 2/3 now. So 3 on 2/3 is equal to 9 on 2. So I'm going to take this one because this term here is missing. So we don't know what normally, if 1 was here, then what we are going to have, we will still have this answer. So if what we had here was 1, we will still have 1/3. So our sum to infinity will still not change in its value, right? All right, so we have 3, all this on that. Question 31. The total number of outcomes of an experiment is called, all right, so that's what we have, right? It's called the sample space. The sample space is the sum total of all the outcomes of an experiment. All right, now question number 32. Question number 32. We have given that Ngalas H, is 3 times APSH in March 2016. And by March 2020, APA was 12 years, 3 months old. Then Ngalas H in March 2016 was. So the first thing we have to do to answer this question is we start by letting, we work with Ngala and APA. So let us form some equations first of all, so that we don't make a mistake with this to interpret the equation. So we start by looking at it this way. So we have Ngala and we have APA. So in 2016, Galas age is, let it be 3x, and APS age is x. This is in March 2016, right? Yeah, so in March 2016, these are the ages that we have, March 2016. Now in 2020, March 2020, that is 4 years later, normally their ages would have increased by 4 years. So this Ngalas age will now be 3x plus 4 years, while APS age would have increased by 4, so plus 4 years. But now we are being informed that in March 2020, APA, March 2020, what happens to APA? So in March 2020, this age corresponds or is equal to 12 years and 3 months. 12 years, 3 months. So from here, we can solve for x, right, using just APA. So what would be the value of x for APA? So x will be equal to, normally this x is in years, right? So from here, we will have x to be equal to 12 years, 3 months minus 4 years. And the value of x will be equal to 8 years, 3 months. So now what would be Ngalas age in March 2016? In March 2016, Ngalas age is 3x. So in this 2016, Ngalas age will now be equal to 3 times what? 8 years, 3 months, right? So 3 times, or 3 into 8 years, 3 months. And what will this give us? This will give us 24 years, 9 months. So his age is 24 years and 9 months. What is sweet question? So we have 24 years and 9 months. So take note of this type of questions. Know that most of these engineering students always run away from this type of questions, but where will you run to? You run and only come back to answer the question. It does not make sense. So what is the period of this function? So for cosine and sine functions, their normal period is equal to 2 pi, right? So when the function is written in this form, look at this, this is just a shift. So we only consider the coefficient of x, right? So this 2x is equal to the period of the function. That is going to give us, this 2x should be equal to, the period of the cosine function is 2 pi. So 2 pi, and it therefore means that now, for us to have x will be equal to pi. So for this particular function, x should be equal to pi. So the period of this function is pi. Okay. Yeah, so the period of the function is pi. So our key here is b, pi. So normally the period of the function t is always equal to 2 pi divided by the coefficient of x. Equation, this one like this does not affect it. So in looking for the period, we don't need this one. This one is just a shift because it doesn't have x attached to it. But what's the coefficient of x here is 2. So 2 pi divided by 2 gives us pi. So the period of this function is pi. Take note of that. Now, question number 34. Guys, don't forget to subscribe to this video. That's the only way you can support us in this work, and to share. Whenever you subscribe, click on the notifications so that you are immediately notified through your email about our uploads. And if we have a class and other things, you're also notified through that mail, and it's going to help you so much. Which of the following series is convergent? Know that a series is convergent. The only series that will be convergent here is a series that is decreasing. For example, look at this first one. It is 2 on 10. The denominator here is constant. So C will not converge. It will only continue to increase. D will also not converge. It will also continue to increase. Now look at the first one. The first one also continues to increase. But the second, 7 on 10, 7 on 100, 7 on 1,000, 7 so until we have 7 on 10 million, 100 million, and so on. So at one point, the value here will be equal to 0. So this is the only function here that will converge. At infinity, the value will be equal to 0. The nth term will be equal to 0. So this is the only sequence that will converge, or series rather. Right now, question number 35. Question number 35. So here we have the mean of this data set below is to find the mean. So we have mark and frequency. And how do we find the mean? For data like this, to get the mean, we just have to do the following. So the mean is each score times its frequency. So we'll have 3 times 4 plus 4 times 3 plus 5 times 5 plus 8 times 3 plus 9 times 2. And what value does this give us? So 3 times 4. So this should give us 12 plus 12 plus 25 plus 8 times 3, 24 plus 9 times 2, 18. So this gives us 24 plus 25, 24 plus 25, that's approximately 49. 49 plus 20, 69, 73, 73, 83, and 91. I just hope I'm right. So this is 91. Now we divide by the sum of frequency. The sum of frequency here is 4 plus 3 plus 5 plus 3 plus 2. So 4 plus 3 is 7 plus 5, 12 plus 3, 15 plus 2, 17. So this is equal to 17. So now here we have 91 divided by 17. So we have 91 divided by 17. What does this give us? So 91 divided by 17 should give us, okay, 5.35 or approximately 5.4. So we have our key here is equal to D. Key here is equal to D. Question number 36. The first derivative of this is, so the first derivative of this is according to the rule. So how do we differentiate these composite functions? Bring down the power 3. We differentiate the core, the function inside this, the core, differentiate the core. We are going to have 3 again. So 3 times 3. So 3 into 3 x squared. Now times the function and subtract 1 from the power. So x to the power 3 plus 1, and all of this raised to the power 2. So which of these? So we have 3 times 3 is 9x squared. Where do you have? We have 9x squared. All right, so this is 9x squared. This is the correct one. So that's the first derivative. Now the value of x for which xy equals 8 and x squared is equal to y is, so we have to find the value of this, the value of x for which xy is equal to 8 and x squared is equal to y. So we can actually do all of this by maybe testing, or we can solve this quadratic equation. So at this point, we will have so at this point, since we already know that x squared is y, so I can go now to equation 1. Instead of writing x, y, I'll have x times, I'll replace y by x squared, right? So x times x squared is x cubed. So x cubed should be equal to 8. Okay. And now what will be the value of x? X should be equal to the cube root of 8. What's the cube root of 8? The cube root of 8 should be equal to 2. So our answer here is B. Cube root of 8 should be equal to 2. Answer here is equal to B. Question 38. Question 38. The limit of 2 minus 1 over n as n tends to plus or minus infinity is equal to, so as n tends to infinity, we'll have 1 over infinity is 0, 2 minus 0 is 2. So the limit is b. Question 39. Question 39, we have the value of x for which 2 to the power x minus 1 equals 0.25 is, and normally we know that 0.25 is the same as 1 on 4. I have questions also on this on the blog. Just go to www.gcmathsfinder.blogspot.com. You're going to have all notes on these lessons, or you go to YouTube, you see all our notes on these lessons. So we are trying to make the basis the same. 1 over 4 is the same as 2 to the power minus 2. So 2 to the power minus 2 now, this 2 to the power minus 2 is equal to this 2 to the power x minus 1. So x minus 1 should be equal to what value? Should be equal to minus 2. So at this point, what will be the value of x? X should be equal to minus 1. X is equal to minus 1. D. Question 40. Guys, as you watch this video, don't forget to subscribe, please. Question 40. Question 14. The perpendicular distance of the point this from the line with equation that is. So how do we get the perpendicular distance of a point from a line? That distance d is equal to the absolute value of 6. You substitute these values of x inside, 6 into 5 minus 7 into the y value. What's the y value there? It's negative 3, right? Negative 3 plus 11. All this on the coefficients of x and y. Square root of that, so the square root of this coefficient. So 6 squared plus 7 squared. 7 squared. So what would this give us? This is the perpendicular distance. So we have 6 times 5 is 30, minus 7 times minus 3. So we have 30 plus 21, which is 51. 51 plus 11, 52, that's 62. So we have 62 on the square root of, what's 6 squared? 36, and 7 squared is 49, right? So we have 62 on root 85. 62 on root 85. All right, now the next question. A radio set, all right, let me bring the page up a bit. A radio set usually costs 40,000 francs, undergoes an increase of 2x% due to inflation. The price of the set after the increase is, so what's the price of the set after the increase? So a radio set usually costs this, undergoes an increase of 2x% due to inflation. So the price of the radio after the increase is, so let us see what we have. So normally, the new price now will be equal to, so let me write down this way. So the new price will be equal to, due to inflation, and there's an increase in price, it should be 40,000 plus 2x%, that's 2x%, times the original price, right? Because it has increased, times 40,000. And when we simplify this, we're going to have 40,000 plus 2x over 100 times 4,000. So these 2 zeros will disappear, cancel out. We'll be left with 2x times 400. So that will be 800x. So if you have 40,000 plus 800x normally, let us see what we have for the answers. Let's see what we have. All right, so the answer is B. We have 40,000 plus 800x. 42, the value of m for which 2x squared plus 2x plus 1 all squared minus 2 equals 2x minus 1 all squared plus m is. So if we expand both sides, let's forget about the terms that are going to cancel out. If we expand both sides, we are going to have, so we are going to have 4x squared on both sides, so I will not consider that. And plus, so we have 2x, so we have 4x. The ones will also cancel out because we are going to have minus 1 times minus 1. So the ones will cancel out. Then we have minus 2 should be equal to minus 4x plus m. So at this point, we'll have 8x to be equal to m plus 2. So this is where we arrive at 2x. So our m now here should be equal to, okay, let's continue to solve, 8x minus 2. Let's factorize and see the answers that we have there. So we'll have 2 into 4x minus 1. 2 into 4x minus 1. Yes, the answer is A. So these students had difficulty. The students could not see the answer. So we have 2 into 4x minus 1. So our key here is A. 2 into 4x minus 1. Our key here is A. Question number 43. The values of x for which ln squared x minus 3 ln x plus 2 equals 0 are. So when you solve this equation, it's like a quadratic, right? So let our ln x be equal to t. We are going to have t to be equal to, we have 3t minus 3, t minus 1 into t minus 2. So we have ln x to be equal to 2. Excuse me, let me take ln x equals 2. So we have ln x to be equal to 2. And the other solution will be ln x to be equal to 1. Ln x equals 1. So from this point here, what will be the value of x? X here should be equal to e to the power 2 of the first case. As the second case, x should be equal to just e. So we have e and e squared as the roots of the equation. That's question number 43. Question 44 is on polynomial. Given that minus 7x cubed plus px squared plus 3x plus 2 leave a remainder of minus 4 when divided by x minus 1, then the value of p is, so if x minus 1, if you divide by x minus, it leaves a remainder of minus 4, it means that this one is not the root, right? So it therefore means that p of 1 should be equal to negative 4. So I'm going to have negative 7. We replace all the x by 1, negative 7 plus p plus 3 times 1 plus 3 plus 2 plus 3, then plus 2. What should this be equal to? It leaves a remainder of negative 4. So I have to put my negative 4 here. That is solve for p. When we solve for p will be equal to, we will have, so we carry this negative 7 to the right hand side. We have 7 minus 4, which is 3. So, so our p should be negative 2. Yeah, so our p should be negative 2. When you solve for p here, you should have negative 2. Question 45. Question 45. The value of n for which n combination 2 is equal to, okay, now I cannot actually get what is written here exactly, but let's see what we can do. So the value of n for which n combination 2 is equal to, so with this one, I cannot be sure of anything that is here. So this question, it is not well written. So it is actually n combination 2 is equal to n over 8 times n permutation 3. So this is what we have. So n combination 2 is the same as n factorial. All that on what? On n minus 2 factorial times 2 factorial. And this should be equal to n over 8 times, now for permutations, we will have n factorial, all this on n minus 2, n minus 2. So this P here is 2 as I saw it. I don't know, they're telling that the value there is 2. So I'm taking the 2. So this n factorial and this one will cancel out. N minus 2 cancel out with n minus 2. And we'll be left with, when we cross multiply, we'll be left with 2n is equal to 8. Is equal to 8. And what will be the value of n? So n will be equal to 4. So in this case, our key will be equal to A. Our key will be equal to A. However, I would just like to make a small note here in case, let me see, you had something like 3, because they are telling me that the value there is 2, but I don't know what if it is 3. So if it is 3, this is what you are going to do. You have n combination 2, so we'll have a n factorial, all this over n minus 2 factorial times 2 factorial, 2 factorial. This one should be equal to n over 8 into, now n permutation 3 is just equal to n factorial, all this over n minus 3 factorial, all this on n minus 3 factorial. So we can simplify, right? This n factorial cancel out this n factorial here. We know that 2 factorial is 2. Then n minus 2 factorial is the same as, so in this case now we're going to have a 1 over n minus 2 times, without factorial, okay? Don't make a mistake. Now times n minus 3. Now factorial, such that these factorials can cancel out, right? And then this side now, so times 2. So there's still times 2 factorial here. 2 factorial. This should be equal to, for this is the left-hand side, right? Should be equal to this right-hand side now, which is equal to n over 8 into n minus 3 factorial. At this point, you can cancel out these factorials now, because this factorial cancel out with this n minus 3 factorial, and you'll be left with, if you cross multiply, you'll be left now with 8 to be equal to, 8 to be equal to 2, of course, this 2 cancel out with this 8 factorial here, will be left with 4. So let me write 4 here. So we'll be left with 4 is equal to n into n minus 2 factorial, n minus 2 without the factorial, sorry. Okay, so at this point now, so we are left with 4 is equal to n into n minus 2. This will give us a quadratic, which will be 4 is equal to n squared minus 2n, n squared minus 2n. So minus 4, but this quadratic, it will not make sense because it has some sort of solution, but this is how you approach the problem. I just want to make mention of this. All right, so question 46. So given that h of x is equal to this and equal to this, and the function is continuous at x equals 2, then find h of 4. For h of 4, which part of the function do we use? For h of 4, we are going to use the second part of the function because the x equals 4 is in this region. X greater than 2, so it's here. So we are going to have, but I don't know what is in front of this x here. So whatever we have there, our solution is going to be as follows. I don't know whether it is 6 or whatever. So it's going to be, whether it's m that is there, we'll have m times 4 minus 7. M times 4 minus 7. So actually, I don't know what is here. So in this case, in an exam, you just have to tick something because if you allow it like that also, it will not make sense. Yeah, so if this one cannot be 1, as you can see. So this looks something like 10. So that's what we have. So you just have to tick something multiple choice. Since the value is not there, you cannot just also leave it like that because we are not penalizing anybody who has ticked something wrong or not ticking. It's not some sort of right minus wrong. 47, e to the power 2 ln 2x is equal to, this is a very, very simple question that always comes all the time. If you hear this one, it means you're not serious. So this one can be written as e to the ln 2x, and it's all of this 2x that is squared, okay? All of this squared. And e to the ln anything is that thing, right? So what will this give us? This will give us 4x squared. 4x squared. Okay, now question 48. Question 48. We have, given that p of negative b on a is equal to 0, then ax plus b is a factor of p of x. So which of them is correct? Is this first one? So this is just what they call the factor theorem. So is this first one? Okay. So ax plus b is a root of p of x equals that. Okay. Question 48. Question 48, we have. All right, now I have to mention something here. This C part looks as if it's correct, but it is not correct because of one reason. This is not a root, this is a factor. If they said it's a factor, this C will also be correct, but it is not correct, so it's not a factor. Ax plus b is a factor, but it is minus b on a that is a root. So that's why the answer that is, the only answer that is correct here is A. Thanks the students who are just who asked about that. Guys, you can join us online for your preparations. You follow our videos to online. Don't forget to join our WhatsApp groups and to subscribe to our channel, because it's through subscription that we know what your needs are and we try to satisfy them. Question 49, the derivative of cos 1 minus x with respect to x is, so you start by differentiating the core. The derivative of the core will be, so when you differentiate the core, you have minus 1. And when you differentiate cos x, what do you have? Negative sine x, right? So negative times this negative here becomes plus. So we have sine 1 minus x, 1 minus x. So this is the derivative. And the last question of the day. So before this last question, please don't forget to watch paper 2 of this work. Check on the paper 2. If there are other questions you have that you like us to answer, subscribe to our channel, click on the notifications, and you can inform us that you like this particular paper to be answered. If you'd like to become a member of the JCE Maths panel, then you can equally go to our channel and indicate that you like to become a member, which is very, very important. That is the technology of today. So the last question, the linear regression lines of a set of data are y equals 1 plus 2x, 1.2x plus 3 plus 30, and x equals 0.432y minus 75. The person product moment correlation R for the data is, so how do we get the person product moment correlation for such a data? So to find the person product correlation R, so this value should be equal to, I want to give you a shortcut, the square root of M1, M2. Now note that for the M, it is the gradient of the curve y equals mx plus c. I call that one M1. While the other gradient M2 is now the gradient of the line x equals M2y plus c. So where this gradient is for the line y equals mx plus c, while the second one is for the line x equals mx plus c. So this is going to give us the square root of 1.2 times 0.432. So the product of this, and that is going to give us 0.72. So this is the product moment correlation of these lines with regression y on x and x on y. Thank you guys so much for watching. And if you have not subscribed up to the end of this video, why not subscribe now? Thank you, stay tuned, and bye-bye. God bless you as you prepare for your exams.